Well, welcome very much. We've got a full agenda today with lots of speakers, and I'm very proud and pleased to introduce our first speaker. Our first speaker is going to be Mike Neuder. Mike is going to be speaking about increasing the maximum effective balance. And Mike is a researcher with the Ethereum Foundation who specializes in staking and proposer-builder separation. Mike?
Hello, hello. Okay, let's get this. Cool. Hey everyone, just gonna start a timer here. Cool, yeah. Hey everyone, thanks for the introduction. I'll be talking about EIP 7251, which is the proposal to increase the maximum effective balance. So just a quick sketch of the talk. I'll start by outlining the problem. So we'll talk about what the max effective balance is. We'll also talk about the partial withdrawal sweep and why that's an important piece of the puzzle. And we'll also talk about kind of what the max effective balance being set at 32 ETH does in terms of the consensus layer. Then we'll talk through some of the solution, so starting with just increasing the max effective balance, and then talking about some of the other features that are important in order to support this and encourage adoption of the EIP. We'll conclude by talking through some of the results and the impact of doing this and kind of the long-term vision for how this fits into the Ethereum roadmap. Cool, let's get rolling. Right, so what is the max effective balance? This is a picture of the constant taken from the consensus specs. Basically, this is the value that's set to 32 ETH, and it caps the upper bound on the effective balance of a validator. So from the consensus layer perspective, the most ETH that a validator can ever have is 32 ETH. And it's kind of confusing because it's actually also the minimum effective balance that it takes to become a validator too. So it's kind of this tight bound on what the consensus layer views as an active validator. And then there's another kind of piece of the puzzle that we need to go through, which is called the partial withdrawal sweep. So again, from the consensus layer, everyone has 32 ETH, but as a staker, as a validator, you're gonna start accumulating rewards for participating in the consensus layer. So as those rewards start accumulating, you need some way of letting people withdraw those rewards without necessarily, because they're not gonna be earning extra yield for that reward. It needs to be withdrawn. And the process by which this is done is called the partial withdrawal sweep. So this diagram tries to show what's going on here, and we're moving kind of left to right as the sweep progresses. We have 3 validators, and this base shows that this is their max effective balance of 32, and they're kind of accumulating some sliver of rewards on top of that for participating in the consensus layer. And the sweep is happening right now for validator number 2. The withdrawals, or the rewards that they earned over the past time period are being sent to their withdrawal credential, and then during the next time period, the sweep will move on to validator 3, and then it'll cycle back to validator 1. So yeah, it just removes any excess balance above the 32 ETH, and it sends these rewards to what's called a withdrawal credential. If the validator doesn't have the withdrawal credential set, then the balance will just accumulate without being withdrawn anywhere. And it takes about 6 days for the sweep to complete one round. So basically, it just does a linear scan through all the validators, starting at validator index 1, going through the end, and then once it reaches the end, it just starts back over. So this shows the set of withdrawals for my validator. It happens about every 6.5 days. I get a withdrawal of about 0.16 ETH. So this is kind of just setting the stage for what changes when we increase the max effective balance and how the consensus sweep works now. Cool. So we're still kind of in the laying the groundwork phase of defining what this problem is. And what results from having a 32 max effective balance is a difference between the pool node operators and the actual validators that they're running. So as you can see here, we have kind of 2 participants in this hypothetical scenario. We have Alice, and she's a pool node operator. And she's running potentially many validators on a single machine that she controls, right? So in this case, she might have 4 different validators that she controls all from the same machine, whereas Bob, who's the solo staker, just has a single validator running from his home box, locally. And what this results in is actually quite a lot of redundant work. So in some ways, all of the validators that are controlled by Alice and that are running on her machine are belonging to, are kind of like logically one entity, but from the view of the consensus layer, there are 4 different entities that you have to verify signatures for, aggregate those signatures for, et cetera. And it also results in a huge number of validators, right? So for these staking pools, they have way more than 32 ETH. And so they have to spin up many, many duplicates of these validators in order to deploy all that ETH into the consensus layer and earn rewards on all of it. And we can see that the actual number of active validators has gone pretty dramatically up since the withdrawals were activated in the Chappelle fork, which was in April of this year. So this is starting around May. We've kind of gone from around, 600,000 all the way up to like 875,000. It was going very rapidly up immediately post the withdrawals, and now it's starting to plateau a little bit, but still we have kind of a few order of magnitude more validators than there are actual nodes in the network. At about 875,000 validators with only around 10,000 nodes on the network potentially, we have kind of a ton of redundant work being done here. And this has direct impact on the performance of the consensus clients. So this is a photo from a document written by Perry and his team, and I highlighted kind of a few of the important points. This is called the Big Boy Beacon Chain Test 1. So this is a testnet that they spun up with 2.1 million validators just to see what would happen, basically. And this is kind of the current versions of the consensus and execution layer clients. And the key metric here, it's a little small, but the key metric says that there was, about 38% of attestations were actually landing on chain. So clearly the network is not able to handle this load. You need 66% of attestations to finalize any blocks. So the chain wasn't finalizing. Just things weren't working at that scale. So 2 million validators is kind of like a 2x increase from what we have today, but still it's within the scope of possibility, especially if there's a huge increased demand for stake over the next years. So another instance of the consensus clients kind of taking a hit is this finality event that happened in May of this year. Essentially what happened is some of the validators were unable to keep up with the head of the chain, and a huge percentage of them went offline. Again, we have a huge drop in the attestation performance, which is one of the key metrics in measuring how the overall network is doing. And it recovered, but the TLDR is that this giant bloated validator set leads to a number of things. It has a very large beacon state, so you have to hold all these validator indices in memory. You have to hold their validating keys. You have long signature aggregation periods, so each validator needs to make 1 attestation per epoch, and that's kind of no matter how big the validator set gets, every one of those signatures has to be aggregated over the course of 1 epoch. So you only have 32 slots to kind of go through, accumulate all those aggregations, and then propagate the aggregate attestations too. So there's kind of huge amounts of overhead there. And also just in terms of P2P networking, if Alice has 4 validators running on her machine, she has to broadcast 4 messages for every epoch because she has 4 attestations rather than a single one that would account for all the stake on her machine. Cool, so that's kind of the problem statement. And the solution is, it kind of sounds simple in principle, which is to just increase the max effective balance. And that's why we call it a modest proposal, because it's a bit of a misnomer, because there's actually kind of a number of other things that we have to do along the way to both make it feasible and secure, and also to increase adoption and make sure that this EIP actually gets used. So this is the 2-line EIP. If it were that simple, that would be great. But one important note here is that we keep the max effective balance, but we make a new variable called the min activation balance. So we want to raise the maximum balance while keeping the floor at 32 ETH. So we still want 32 ETH to be, accessible to home stakers and hobbyists, but making it the upper bound 2048 ETH in this case. Will hopefully allow the big staking operators to consolidate and merge their validators into smaller sets. Cool. So one of the core, features of this EIP is that we need validators to merge without exiting the consensus layer. So again, we have Alice here. She has 4 validators that each have 32 ETH, and we want her to be able to combine them into a single validator that has 128 ETH. Once she does this, she can throw away the signing keys for validators 2 through 4 and just do everything under the validator number 1 index. And the reason we need this index merging to take place is because if we have 870,000 validators and we want to consolidate them, we need the adoption of the staking pools because they're the ones who are running like all the stake. They have all these signing keys, and in order for them to adopt it, they need to be able to merge without exiting the consensus layer in order to avoid the process of withdrawing all 4 of those validators, combining the stake into one new deposit, and then going back through the activation queue. So that life cycle there is, I guess, prohibitively slow, especially for pools that are trying to compete on APY. So in order to incentivize them to do it or to kind of lower the cost of doing it for them, doing it in without having to exit is a very important feature. Like it's kind of a must-have from their perspective. Another thing is either choosing enabling custom ceilings or execution layer partial withdrawals or both. So it's kind of a lot of jargon there, but basically the idea here is that if someone's running a validator with say like 1,000 ETH, they need a way to signal that they want some of that ETH out without necessarily withdrawing the entire validator. You could think of this as they might need to pay their tax bill or they need to pay the cost of running a large node, but essentially there needs to be a way of simplifying the process of withdrawing stake, given that the sweep might not be effective for people who have a very large effective balance. So there's kind of 2 ways to do this. The first one is these custom ceilings. So this diagram tries to kind of highlight what we have. We have the same sweep progression as before, so we're moving left to right. But the 3 validators now have different ceilings that they set. So validator 1 set a 64 ETH ceiling, validator 2 set a 32 ETH ceiling, and validator 3 set a 96 ETH ceiling. So the sweep will still move like left to right and then circle back and go back to validator 1, but the amount that is swept off will change depending on how much stake each validator has. So in particular, validator number 3, who has a lot bigger balance, will have 3 times the amount of rewards that get swept off in through each sweep, but they still are able to kind of fine-tune where they want that ceiling to be. And in the ideal world, all the staking pools would set the ceiling all the way up to 2,048 ETH, and that would be like a full consolidation, a full 64 times consolidation of all their validators. We expect that the adoption would probably be a little more gradual in terms of, maybe they combined 4 validators into 128 ETH validators and then 2 of those into 256, et cetera, kind of like building up trust in their setup and reducing the risk of any larger slashing event. But that's the goal, is to have validators have more control over where the sweep kicks in for them. Alternatively, we could have what's called execution layer partial withdrawals. That's a bit of a mouthful, but basically the idea here is that the withdrawal credential is the place that effectively like owns the ETH from the view of the execution layer, right? Like when you initiate an exit from the consensus layer, the ETH goes to the withdrawal credential. This is just an EOA. It could be either a contract it could be an EOA or a contract. And EIP 7002, which was written by Danny, is this idea that we could have exits triggered by the withdrawal contract. And this idea of execution layer partial withdrawals just kind of extends this to say, not only can you exit from the execution layer address, but you can also initiate a partial withdrawal. So this would help both the staking pools and solo stakers like kind of maintain control over their validators without necessarily having to worry so much about only one key being able to withdraw ETH from their validator. Cool. Another part of the solution space is potentially changing the slashing penalty. So the slashing penalties on Ethereum are really complicated, so I won't go into too much of the detail, but the important thing that we're going to pay attention to is what's called the initial penalty. Okay. The initial penalty is basically applied to a validator balance immediately once they commit a slashing violation. And right now we have power set to 1. So what this means is we have effective balance, which is usually 32 ETH for all the validators. So the initial penalty is 1 ETH for a slashing condition in today's version. But the problem with this is that it would scale linearly, and that would be very punitive for anyone to consolidate. So if a staking pool consolidated 64 times, then that one validator, if they get slashed, would be slashed 64 ETH, which is quite bad. So we could instead potentially scale it sublinearly, and we don't even have to necessarily do this form of scaling, but this is like one potential option. You could imagine, the text is a little small here, but you could imagine like a constant slashing penalty that's applied for everyone, or you could imagine the penalty scaling as like the square root of the effective balance rather than linearly in the effective balance itself. Cool. So what does this actually get us? It cleans up some of this historical tech debt. So I guess a little of the reason for why this validator balance was set to 30, or the max effective balance was set to 32 ETH in the first place, is that the original sharding design required an honest majority of each subcommittee within the consensus layer. And so in order to ensure that the subcommittees weren't like biased in any direction, you had to set this ceiling in order to make sure that there's good representation of the honest majority in each subcommittee. But with the new design, with sharding not the execution, but just sharding the data, we have a situation where we only use that committee for attestation aggregation, which is a 1 of n honesty assumption rather than a majority honesty assumption. It also improves the network stability. This kind of circles back to the ideas from before. And it also enables this auto-compounding feature and flexible balances for solo stakers. So just a quick before and after. Without this auto-compounding feature, the solo staker will only ever have 32 ETH until they accumulate enough ETH to deploy another 32 ETH validator, right? And this is like many, many years potentially in order to get that. Versus post increase to the max effective balance, they immediately start earning extra rewards for all the rewards that they earned in the first place. So you have this kind of compounding effect. The staking pools already get this because they're big enough to deploy new validators constantly, but solo stakers don't have access to this. And flexible balances just means like if you have 40 ETH and you want to have a 40 ETH validator, you don't have to deploy that 8 ETH somewhere else. You can do it all through your solo staking. It also opens up the path to single slot finality and potentially aims to decrease the min activation balance. So this is, if we get good adoption of this EIP, we could potentially get into a world where you actually reduce the 32 ETH minimum down to like 16 ETH or 8 ETH and make solo staking and home staking more accessible. So thank you very much. This QR code sends you to this GitHub gist, and it should have all the links you need to read more on this. So thank you very much. Happy to take questions.
Yeah, thank you very much. We have time for one question here, but we're hoping to get a mic working. Oh, perfect, there it comes. Just because there's a number of folks being live streamed here.
Hello, thank you very much for this. And I got a question regarding entry and exit queue and churn limit, because currently we have, like churn limit equal to amount of validators. And if I understand correctly, in case of this heap, it would be switched to balance, or like how it would work in this, like how validators would enter, especially if I would like to make one validator which is 2048 ETH. So will it enter like one validator, or I need to wait several blocks? Like how this will work?
Yeah, exactly. Thanks. And that's exactly the type of question that the EIP tries to address. So yeah, the context here is that currently the churn limit is rate limited by the number of validators, but we change it to be rate limited by the amount of stake of that validator. So if you deploy a 2048 ETH validator, it might take several epochs for it to activate, and that'll be the only validator that's activating during that time. So it's kind of like you're just throttling it based on the amount of ETH coming in rather than the number of validators. So yeah, and happy to talk offline about the technicals there. It's a cool part of the design.
Okay, perfect. I think we have time for just one more question here. Does anybody have a question for Mike? All right, I did have one, Mike, maybe you mentioned it. When you combine your validators, if you're running multiple validators on your node, do they have to have the same withdrawal credential, or how does that work?
Yeah, so if you combine them, it will have to, the one validator that you combine into will have to have the withdrawal credential that you choose. So the way it's written now, you kind of merge them into an existing validator. So you choose whichever one has a withdrawal credential that you're happy with the larger validator having, and then you do that. I don't think it would be worth the complexity of engineering it so that there could be multiple withdrawal credentials for a single validator. That would be a bigger change, but yeah.
Perfect. Well, again, thank you very much for kicking us off today.
Yeah, thanks for having me.